Hey friends. Okay, so we're going to take a look at lesson 7 today, which is integration by parts. Integration by parts is another tool we have to integrate things. One of the big questions that will come up for you as we start going through this is you're going to say, well, how do I know that I should be using integration by parts right now? Well, don't stress, chill out. The quick and easy conversation around that is if you don't know what else to do at the moment, do integration by parts, okay? Because you have to remember each one of these are tools and the tools get more complicated as we go. And so if you can't integrate by a simple way, then try integration by parts, see if that's going to help you out. Okay, but in order to do that, I first have to walk you through where it comes from. Okay, so here's what we already have. These are already the kind of tools that we have in our toolbox when it comes to integration. Okay, the first is the power rule. We know that if we were to integrate x to the n, what happens is that exponent goes up a degree, and then I take the coefficient in front and divide it by what the new exponent is. So that's where that x to the n plus 1 all over n plus 1 plus c is. Now, that all works as long as n doesn't equal -1. If n equals -1, that's 1 over x now, right? And that was a separate one. The integration of 1 over x was ln x plus c, okay? So those two kind of combine together to form the integration for powers. Okay, then we've talked about the substitution rule. We've also already talked about easy trigonometric and exponential functions, okay? How to integrate those guys. Now, remember that everything in math is bidirectional, okay? If I can go one way, I can go the other way. So for every tool that I have for differentiation, that means I have some sort of tool to take that answer and anti-differentiate it back to wherever I started from, okay? So the substitution rule that we talked about the other day was really the way to handle the chain rule, okay? It's the reverse of the chain rule. So for every different differentiation rule, there's a corresponding integration rule. To obtain the substitution rule, what we essentially did was reverse the chain rule. Now what we're going to do is play around with the reversal of the product rule. Okay, so you will recall the product rule was when I'm differentiating f of x times g of x, it's the derivative of f of x times g of x plus f of x times the derivative of g of x. So what we're suggesting is how do we reverse that and anti-differentiate that? Okay, so the product rule we can reverse by using this process called integration by parts. And that's what I kind of want to walk you through at the moment, okay? Okay, so first little few minutes here, we are going to try and develop the formula for it, okay? So next on our list is to undo the product rule. How do we integrate this? Now I want you to notice that I put this as pink because as that little piece appears in the next little section, I'm always going to make it pink just so that we have an idea of that's what we're trying to look for, okay? So we're looking for the integration of f of x times the derivative of g of x, okay? That's what we're looking for. Now, recall that the product rule states, I just said that, the derivative of f of x times g of x is the derivative of f of x times g of x plus f of x times the derivative of g of x. And we also know that the opposite of differentiation would be to anti-differentiate or to integrate. Okay, so what I want to first do here is I'm going to take this and I'm going to integrate both sides. So I'm going to say, hey, I'm going to integrate this side, I'm going to integrate this side, and I'm going to play around with that. Okay, and that's what this looks like here. If I can just take off my ink. Oh, sorry, and then I need to get back to my mouse. Okay, so that's what I've done. I've just integrated both sides. Okay, now, couple things I want you to notice here. The integration of a derivative is just the original function, right? Because I'm integrating a derivative. So that just becomes f of x g of x on the left side. On the right side, this integration can carry forward to both of those separate pieces that are being added together, okay? And so that's what I'm going to do. And then you'll notice this pink guy is what I'm searching after. My original conversation was around how do we integrate something that looks in that form, okay? Okay, so that means I just want to take this and rearrange it so that the pink is by itself. So I'm going to essentially subtract the integration of the derivative of f times g of x, and that will get me the integration of f times derivative of g of x all by itself. Okay, I'm just trying to isolate the pink right now. Okay, and so that gives me the following. Okay, so the integration, I originally started this conversation saying, how do we integrate what that pink statement is? How do we integrate f of x times the derivative of g of x? Well, the integration of that will be f of x times g of x minus the integration of the derivative of f of x times g of x. Okay? Okay, so now, when we do this, we often don't use f of x and g of x, we use u and v. So in a minute, I'm going to switch this to u and v, and that just simplifies our lives a little bit. But before we do that, let me walk you through an example. I want to integrate ln x dx. Now, this one's a little tricky because, hey, I don't see this as the product rule, okay? But then my next question would be, well, what am I going to do with it? Do I know anything right now on the integration of ln x? I know how to integrate and get ln x, but nobody has ever talked to me about the integration of ln x. So what I want you to think about with this guy is almost think of this as 1 times ln x, if that makes a little bit more sense in your head. So what we're going to do is we're going to let f of x equal ln x. And then g of x is essentially 1 dx. Sorry, I said g of x. I should have said the derivative of g of x there. Okay, so now if I have the derivative of g of x being 1 dx, what's g of x? Well, g of x would have to be x, right? Because the derivative of x is 1. And then for ln x, the derivative of ln x is 1 over x. Okay? So I have f of x and I have the derivative of g of x that I have to gather from my equation. Okay? So I essentially said, okay, here's f of x and here's my g of x. dx would just be 1 dx, right? So then I have to take the derivative of f of x and I have to take the antiderivative of 1 dx. The derivative of f of x is 1 over x, and the antiderivative of 1 dx is x. Okay, now I'm just going to put all these pieces together. Don't shut down on me. We're just going to put all these little pieces together. And so we are going to say the integration of ln x has to be f of x times g of x minus the integration of the derivative of f of x times g of x. So I'm just going to plug the pieces in that I just talked about, and I would get this. F of x was x, g of x was ln x, and then I'm going to minus the integration of the derivative of f of x is 1 over x, and gx was x. Okay, so now I have to do this integration. 1 over x times x is 1. And the integration of 1 would just be x. Okay, so I end up with x ln x minus x and then plus c. Okay, now what the heck just happened? Well, a couple of things just happened. What we've done is we have found the antiderivative of ln x. The antiderivative of ln x is x ln x minus x plus c. How do I know that's true? Well, I would need to take the derivative of x ln x minus x plus c. If I take the derivative of x ln x minus x plus c, I should end up with what I started with, right? Which is ln x. So let's give it a try. Let me clear the ink here. So what did we just do? We found the antiderivative of ln x. Want to prove it? You know you want to. So let's take the derivative of x ln x minus x plus c. So if my equation is x ln x minus x plus c, and I want to take the derivative of it, this guy here is the product rule. So that will be 1 times ln x plus x times 1 over x. The derivative of this will be minus 1, and the derivative of this will be 0. So I'm looking at this right now. So that's ln x plus 1 minus 1, which is ln x. And so the derivative of x ln x minus x plus c is in fact ln x. So we have, through integration by parts, taken the antiderivative of ln x and found out that the antiderivative of ln x is x ln x minus x plus c. Okay? Okay, so as I had said earlier, we're not going to actually set this up with function notation. Instead, what we're going to do is we're going to let u and v be the differentiable functions of x. Okay, so then that becomes the product rule for differentiation. Now it looks like this. So if I took the derivative of u times v, that would be u times the derivative of v plus v times the derivative of u. Okay, then we're going to integrate both sides, just like we did when it was functions, okay? But now the integration of the derivative of uv, which is vub, and then what I'm looking for is I want to rearrange it so that I have the integration of u dv by itself. So the integration of u dv will be uv minus the integration of v du, okay? And that is the sort of formula that we use to do integration by parts, okay? So the integration of u dv is uv minus the integration of v du. The above formula has 4 unknowns. 2 of these, u and dv, we will assign to the expressions in the original integral, because that's what we were trying to figure out, right? So one of them we define as we define as u, and one of them we define as dv. The other 2 variables, v and du, will be determined by differentiating u and anti-differentiating dv. Okay, so in general, u is a function that will eventually differentiate to 0, and then dv is a function that's usually easy to integrate. Okay, all right, so let's try a few examples together then. First one we're going to look at is x cubed ln x dx. Okay, the integration of x cubed ln x. So what should we let u be? And then the other guy will have to be the dv. Okay, so we're going to let u, which one is easier to anti-differentiate? Well, I know that like the very first question that I gave you was anti-differentiating ln x, right? And we realized that that was not super easy to anti-differentiate. So x cubed is easy to anti-differentiate. So I'm going to let u be ln x, and I'm going to let dv be x cubed dx. Okay, now I need to take the derivative of ln x, that'll be du, that's 1 over x. And then I need to take the antiderivative of x cubed. Well, the antiderivative of x cubed would be 1/4 x to the 4 plus c, right? But we'll ignore the plus c. Just take out that plus c. Okay, so now I go to my formula and I just plug in everything that I know. Okay, I know u, I know v, I know v, and I know du. Okay, so I plugged everything in. U was ln x, v was 1/4 x to the 4, minus the integration of v, which is 1/4 x to the 4, times du, which was 1 over x dx. Okay, and you can see that my integration works out. I have dx here, and I'm only using x's inside here, so all of that worked out. So that's going to actually be 1/4 x to the 3. Okay, and then the other thing I did here is I just took my x to the 4/4 and brought it to the front. Okay, and then I took my 1/4 and brought that out to the front of the integration as well. The integration of x cubed, well, the 3 will become a 4, so that's going to be 1 over 4 x to the 4. And then I've got that negative 1 over 4 in front. So negative 1 over 4 times 1 over 4 is going to give me negative 1 over 16. So I'm left right now with x to the 4 over 4 ln x minus 1 over 16 x to the 4 plus c. That is the integration. Okay. All right. Now, how would we check that? Well, if I want to check that, I would want to take the derivative of this guy and see if I ended up where I started, right? So let's do that. We're going to take the derivative of this guy. This becomes the product rule. So we have the derivative of f, which would be the 4 would come to the front, and then that would be x cubed. So that would be x cubed ln x plus x to the 4 over 4 times the derivative of g, which is 1 over x. And then this guy, the 4 comes to the front, 4 over 16 would be 1 over 4, x cubed. Okay, so now when I go to clean this up, x to the 4 over x would give me x to the 3. So that would give me x to the 3 over 4. Then I see x to the 3 over 4 minus x to the 3 over 4 is nothing, and I'm left with x cubed ln x. Okay, so I did in fact end up getting what I had in the original spot. So integration by parts is a way to anti-differentiate functions that would have involved the product rule had I been going the route of differentiating. Okay. All right, so let's try another one. We're going to try x times 1 minus 5x to the 7. Now remember, u is something that we want to differentiate easily, and we want to be able to differentiate it eventually down to 0. And so x is going to be u here, which means dv is going to be my 1 minus 5x to the 7. Okay, so now du will be 1. Okay, and then I have to figure out v. Well, in order for me to figure out v, I have to integrate 1 minus 5x to the 7. So to do that, I'm going to do a quick u substitution to get that one done. So u is going to be 1 minus 5x. So du is going to be negative 5. Swap it out so that it's dx. dx will be negative 1 over 5 du. So now to do that integration, I'm looking at the integration of u to the 7 times negative 1 over 5 du. The negative 1 over 5 can come to the front. The integration of u to the 7 would be 1 over 8 u to the 8. Okay, and now that tells me what my v is. I need to replace my u again with 1 minus 5x. So this is going to be negative 1 over 5 times 1 minus 5x to the 8 over 8. So I'm going to put that in for v. Okay, so now I have all my parts. I've got u, I've got dv, and I've got v, and I've got du. So I'm going to plug all those into my integration by parts formula. So it's uv minus the integration of v du. Okay, so u is x, v is this mess, minus the integration of that mess again, and then du. So it's going to look like this. Now, we're okay. We're just going to take it piece by piece here. So the negative 1 over 40 can come to the front. So that'll be plus 1 over 40. So that's the first thing I'll do here. Okay, I also just brought the x up there. Now, you have to think this through. You might want to do another u substitution in order to integrate this properly. I'm just going to do this one in my head, though. I'm going to say, hey, my 8 becomes a 9. So this is going to be 1 over 9. And I've got 1 minus 5x to the 9. But then the problem is that I have to deal with that inside function as well, right? So I'm also going to need a negative 1 over 5 there. The reason I need a negative 1 over 5, just think about that. When I take the derivative, I would end up taking the derivative of the inside function, which would end up being a negative 5. So I have to have something that I'm multiplying by to divide out the negative 5 that appears. Okay, so I end up with my 1 over 9 my negative 1 over 5, and the 1 over 40 that was there originally. So what can I do to clean it up now? I can multiply the 4 times 5 times 9. So that'll be negative 1 minus 5x to the 9 all over 1800. Okay, so my integration is negative x times 1 minus 5x to the 8 all over 40 minus 1 minus 5x to the 9 all over 1800 plus c. Okay. All right, next one. I'm looking for the integration of 2x cos 6x. So I'm going to first bring that 2 out to the front and just look at x cos 6x. Okay, so my u value is going to be x, and my dv will be cos 6x dx. Now, du will be 1, and I got to figure out the antiderivative of cos 6x. Well, that would be 1 over 6 sine x 6x, right? 1 over 6 sine of 6x. Okay, so I plug all that in. So my u is x, my v is 1 over 6 sine 6x. Then I'm going to minus the integration of 1 over 6 sine 6x dx. Okay, so now just notice too, my 2 is going to have to get applied to both of those terms because I brought the 2 into the front. Okay, okay, so the integration of 1 over 6 sine 6x, well, the 1 over 6 can come to the front of my integration symbol, and then the integration of sine 6x would be negative cos 6x with 1 over 6 in front, so negative 1 over 6 cos 6x. Now, that ended up being a positive because I had 2 negatives there, okay? I just go back here, this was negative, and then I ended up with negative 1 over 6 cos of 6x, so that's where that positive is coming from. Okay, so 1 over 6 times 1 over 6 is 1 over 36, and then I'll bring that 2 in. So 2 times 1 over 6 would be 1 over 3, and then 2 times 1 over 36 would be 1 over 18. So my final answer here would be x sine 6x over 3 plus cos 6x all over 18 plus c. Again, what did we just do? We just integrated the original function. The original function was 2x cos of 6x. If I now took this and figured out the derivative of this, I would end up with 2x cos 6x. Okay. All right, now we're going to try to integrate x e to the x. So again, I'm going to let my u be x. So that means my dv has to be ex dx. The derivative of x is 1, so I'm looking at 1 dx. And then the antiderivative of e to the x is e to the x. Okay, so I'm ready to plug everything in. My u is x, my v is e to the x. Then my v again is e to the x, and du is dx. Okay, so now I need to take the integration of e to the x. Well, the integration of e to the x is e to the x. Okay, and so my final answer here will be x e to the x minus e to the x plus c. Okay, I'm smirking because sometimes I feel like I'm rhyming this off and like making your head spin, but just keep reviewing this. Go back, watch it through again. You're going to get it. It's going to feel okay. Okay. All right, awesome. So that's where I leave you. Your homework is posted here, but I never leave you. Make sure you connect with me with any questions that you have. Okay, you guys got this. Take care. Bye-bye.